So, hello, good afternoon. Welcome to our webinar today. The topic is the PV Point, our basic backup solution for the Gen24 Plus inverters. Basically, I'd like to introduce first of all, our team. So it's myself, my name is Hans Pelzer. I'm doing the presentation for this next about 30 minutes. And beside me is Michael Ronick. He is in the chat. He will answer your questions. So feel free to send us your questions during this webinar, and we will answer that immediately, also after this session again. Good. What I would like to introduce you now is basically first a little bit in general about the Gen24 Plus inverters, about the backup power function. Then especially the PV point operation and the technical specifications. Then as well, I'd like to show you the installation and commissioning. So what you need and how you do that to do the commissioning. And basically, finally, the benefits and some additional information about the PV point. What is the Gen24 Plus storage solution? Basically, it consists of three components. The Gen24 Plus inverters, in this case, the SIMO, in the power classes from 6 to 10 kilowatt, three-phase. So there's also an 8 kilowatt unit, three different power classes. And these inverters come with 2 MPP trackers and also 1 battery input. Additional to that, you need the Fronius smart meter, which you can see just on top of that. This is the Fronius smart meter to measure the power on the feeding point and gives the information to the inverter what's actually going on there. And third, it's also coming with 2 backup power solutions, the PV point and the full backup solution. I would like to explain you in this webinar, especially the PV point basic backup power solution. There's another webinar where we introduce or where we explain the full backup power solution as well, which is on YouTube available. And the battery, for the battery storage, we use the BYD Premium HVS or HVM. And you can use different power classes from 5.1 to 22.1 kilowatt hours. So these different power classes are available. So look on our webpage to see the right battery size, which is compatible to these inverters. And good news about the Gen24 Plus inverter, the SIMO range is now available. So we offer that product on the market. So as of today, the installers in Austria, Germany, and Europe will get the first shipments of this inverter. Now let's have a look at the basic setup of a Fronius storage system. When you start with the PV generator and the inverter, you see that there is the Fronius smart meter at the feeding point right after the utility meter. There's also communication line between inverter and Fronius smart meter necessary. So this is 3-pole shielded cable, Cat5 standard. And also this communication goes to the battery. Same communication also for the battery. And you see the BYD battery where you connect plus-minus pole to the Fronius Gen24 Plus inverter. The loads are in the middle. So with that, we detect on the feeding point the surplus energy which is available, and all surplus energy which is not needed from the loads at the moment will be stored in the battery storage. This is the basic idea about this system. Now let's come to backup power solutions with this inverter range. There is actually 2 solutions. First of all, the PV point, which is on board. There's no additional you don't need any special additional components in the inverter. And it's basically a socket of where we offer 230 volt AC single phase supply. So we can connect here different loads. And then on the other hand, we have the full backup solution. Here we supply the entire household, so we can have a real 3-phase output, and but this requires additional backup power switch. So you need here different contactors, relays in the switchboard to switch over from grid connected mode to off-grid mode. And therefore you need separation, and therefore you need these components. But this is, as I said, not necessary when you have a PV point. And also you need, on the full backup solution, you need the battery storage. And without that, it would not work. So now let's come to the PV point operation. So how does it work? You see here again the basic setup. And now when the grid is, when there's a blackout or the grid supply disappears, then the PV point will come into operation. The PV point is, let's say, 230 volt socket here connected directly on the inverter. And then we supply this once at first from the PV generator during the daytime, and also secondly from the battery storage at nighttime. We can also still store the energy in the battery, of course, but basically we use the energy only for our loads, which are connected to this socket here. And it's single phase. It's up to 3 kilowatt nominal power. And for starting performance, we can offer up to 4.1 kilowatt for about 5 seconds. The supply is, in case of a grid outage, there is an interruption for about 60 to 90 seconds, so different on the different inverters. On the SIMO range, it's about 90 seconds at the moment. And the power supply will then start automatically again on this socket when there's a grid outage. We have an on exit for the inverter, and there is no additional installation necessary. So no this kind of box where you have the smart meter and the contactors and fuses integrated. This is not necessary with the PV point operation. And of course, with that you save money, because basically you can say these components and boxes cost you, including work, maybe 1,000 euro or something. But now, if before I would like to continue, I would like to ask you one question. I tried to get my poll now started. I hope it is working now. Yeah, it seems to be good. Basically, the question is, which loads are most important in your case to run in backup power mode or in this PV point operation? What would you connect here on this socket in the case of a backup power mode? Is it the heating system? Is it the air conditioner? Is it the refrigerators? Is it supply of the internet router, mobile phones, laptop, TV, whatever, you know, all these smart devices in your household to communicate? Good, I see already there are already 60% answers. I would like to continue a few more seconds. And yeah, I think that's perfect. Great. Thank you very much for your feedback. I'd like to show you as well now the result. Basically, most of you see the refrigerator and the supply of the internet router, mobile phones, laptop, and so on as most important, and air conditioner heating system is not so important. Basically, there would be possibly also other answers possible, like a water pump or whatever. But I just figured out these few things here. And of course, one thing is important. These usually there is no issue with these loads, but the heating system, of course, if it's a heat pump or a bigger heating system, electric heating system, would of course be too much to be supplied from these PV point solutions. So it's basically, as you also have mentioned, basically for the refrigerator and supply of some small loads to communicate to via the internet. Good, great, thank you very much. And now I'd like to continue with the installation and commissioning. There is basically the schematics, how it is connected. Basically, on the inverter, you have a 3-pole connector, and on this 3-pole connector, you see 2 neutral, 1 phase. And all you need to do is you go with 1 neutral to the PE terminal, and then you connect there the ground cable. Additionally, you would need an RCD 30 milliamp type A, but no fuse here because there's anyway only a maximum output of 13 amps possible. As soon as we have a higher load, the inverter would stop working and would then try again in a few seconds, and then try again after again a few seconds, and after a while, after the 5th start, he would then stop operation because the load would be too high, and then you would need to disconnect the load. Otherwise, of course, the inverter would not start running in PV point operation. If we go into the pictures to see how it's done, you see here the specific 3-pole connector. This is in the inverter, just beside the AC connection. So when you have a SIMO, you would have then here 3-phase connection, of course. In this case, it's a Primo, which will be launched later, beginning of next year. There is an interconnection between neutral and ground, the ground terminal, and then you go from that to the output to the socket. On the socket, you have different. There's also a possible one that integrated RCD, which is maybe quite expensive. There is, of course, another possibility to just connect the RCD anywhere, just in an extra box right after the inverter, and then you go to the socket. The cable outlet or inlet will need a drilling hole, and you then get your cables out here on this white cable inlet. That's all you need to do, basically. And then again here, the wiring of the inverter. You see here the neutral connection to ground to make these operation of the RCD working, because on the RCD we measure the ground current. Therefore, we need that. Yes, if you did the installation, then you just need to do the commissioning. Basically, one only very easy step. You open the access point of the inverter. You just press the button in the middle of between the two LEDs, and then the access point is opening, and you connect your smartphone where you have the new Fronius SOLAR.START app already, which will be launched as of today, and actually maybe later on this evening, this Fronius SOLAR.START app will be available. And with that, you do the commissioning, and under product, you will find the points for the general settings, which means the time and the setup, the system overview where you add the components like a battery or a smart meter, and under the point features and pins, you will then need to start the emergency power mode. And under emergency power mode, you will find then these two operation modes, PV point or full backup mode. And here you can then select, in our case, PV point, and then you get the output power of 230 volt AC for your PV point socket. When it's operating, it shows as well on a display or on your smartphone. You can see the current power, what is produced, and also the loads. In this case, I have a very low load of only 9 watt, and the inverter is running in PV operation, and the smart meter is missing because we have here, in this case, no smart meter connection in the PV point operation. So that's it. So easy to see what's going on, and all that can be seen as well in Solar Web, of course. Good. Then last point, additional information. What additional information? Again, to repeat, the advantage is basically PV point is 3 kilowatt backup power for one single phase socket. Easy installation. You don't need a high cost additional equipment, and also automatic switch over from grid connected mode to PV operation within these 90 seconds. So in this moment, you will the inverter will then start again and supply the loads with which are connected on this one socket. Yeah, basically that's it. So a real easy basic solution, maybe for customers who would not like to invest in a full backup power solution, or maybe the ones who say, okay, I'll start with that because that's easy. And whenever I get more often grid network outages, then you can always go to the full backup solution as well later on. Good. If you need any additional information, we have on we offer from Fronius webinars to these topics as well, trainings, other trainings like the Fronius storage solution. We offer as well webinars like Gen24 backup power mode, full backup power in this case. These videos are also available on the Fronius YouTube channel, so you can find that easily there, and also documents the PV point quick guide, which we will send you tomorrow. So you will receive tomorrow this recording and as well the presentation and this PV point quick guide, quick installation guide. And of course, don't forget the Fronius SOLAR.START app, which is a very easy tool on your smartphone to do the commissioning, and with that you have everything you need to get the inverters into PV point operation. Good. Now that's all so far from my side, and I would now like to ask Michael if he could maybe answer or answer a few of the questions which we have received. Therefore, maybe Michael, could you?
Thank you, Hans, for the webinar. And of course, we received some questions during the webinar that we want to answer now. So first question is the question about the automatic switchover of the PV point. So what is the status of the PV point when the grid is available? So first of all, when the grid is available, so when there is no grid blackout, the PV point is deactivated. So the PV point gets activated as soon as the grid fails. So when there is a grid blackout, then the PV point will be activated by the inverter. As soon as the grid comes back, then also the PV point is deactivated again, and waits for his next activation when there is a grid blackout again. So under normal circumstances, the PV point is not available. Second question we received then is about the SolarWeb premium account. So the question was about if there is a smart meter needed in the system with the Gen24 Plus, and if there is SolarWeb premium account needed. So first of all, the Fronius smart meter is always necessarily for visualization of a system. So if you want to gain information about what's going on in the system and about energy visualization, then you need the Fronius smart meter for visualization of these energy flows. Second on, it is then possible, of course, to use our free Fronius SolarWeb version. So this is always free of charge, and you can just log in, register there, and add on your new PV system. After that, you have the second possibility to opt out for SolarWeb Premium. And with these premium functions, it is then possible to gain different functionality like the daily view curve, so you can access several days in the past, and like other many useful functions that are out there with SolarWeb Premium. So please just check that out on our solarweb.com website page, and there you can see all information about the SolarWeb accounts. Okay. So first of all, we will stay online for your questions. So if you have any further questions, please feel free to send us them, and we will stay online for your questions now. I will hand over to Hans for the last words.
Okay, Michael, thank you very much. Good. Yes, let's say we hope you can use this information and hope this PV point solution is something which is a good selling point for you for your installations, and the customers will, I'm quite sure, also like that solution. Yes, thank you for participating. Hope you come join again one of our next webinars or trainings. Feel free to contact us if you have any questions, and I'd like to wish you a good afternoon and stay healthy, and all the best for until next webinar. Thank you very much, and goodbye.